This one's called factoring a difference of squares. The reason it's called a difference of squares, these look like this. Something like this, where there's a difference, which means a subtraction problem, of squares, which means things that are squares. Squares meaning something times itself, like x squared is a square, x times x. 100 is a square, that's 10 squared. Or in other words, 10 times 10 is 100, so that's what a square means, something times itself. So if you see a difference, which means a subtraction problem of two things that are squared, it factors pretty easily. What you need to remember is this should have been a trinomial. See, this is a squared, so there should have been a first power of x. But there's nothing there, so we will say x squared plus nothing times x minus 100. This is another way to think of this. And you'll remember from factoring trinomials that all you have to do is ask yourself what multiplies to the last number and adds to the middle number. I'll fill in my x's. You'll see that in order to multiply to the last number and add to the middle number, these two numbers must be the same number, only different signs, because it's got to add to 0, which means they have to be additive inverses, or in other words, like negative 10 and positive 10. These are going to give me nothing when I add it together, just like what I need. So this would be minus 10 plus 10. Now you don't have to show all this every time. If you'll just recognize this is a difference of squares, you just come down here and you write your x and your x, and that's what multiplies to x squared, and 100 is a 10 and a 10. And you need to remember that since this is a negative 100, this needs to be a positive 10 times negative 10, and that will give me negative 100. That's all you have to do to factor a difference of squares. Sometimes the difference of squares might look like this, and you'll factor that just like I just said. Put your x and your x in. That's pretty easy. 9 times 9 is 81, so that goes here. Negative 9, positive 9 makes negative 81. Well, the deal is you're not done there because, well, this one is done there. Sometimes they look like this. Let's try that again. And this would be x squared minus 9 and x squared plus 9. And you will see that x squared times x squared is x to the fourth. Negative 9 times positive 9 is negative 81. And you'd think, well, I wrote down my two parts, I'm done. Only this one can be refactored. See that x squared goes back to x and x. Negative 9, two things multiply to that, that would be negative 3 and positive 3. So this is a difference of squares in itself. And then we'll bring down the other part that doesn't have, this part can't be refactored, so I'll just bring that down here. This part can be rewritten as this part. So x to the fourth minus 81 can be factored and then factored again. Sometimes you got to be careful of that. Okay, let's check this one out. This one is definitely a difference in of squares. Well, this is definitely a square. You got to ask yourself, is this something times itself? So 2x times 2x will give me 4x squared. So this is a square in itself. So that means that this factors as a difference of squares also. So see, this would be a 2x and a 2x instead of just an x and an x. 49 goes to 7 and 7. But I need a negative 49, so this is a negative 7, positive 7. And that's really it with difference of squares. It's pretty easy once you get the pattern down if you can just recognize that this is a difference of squares. These are the easiest thing to factor.